Amira, welcome back.
Hello.
Amira, do you have any siblings?
Yeah, I have a brother.
Only one?
Yeah.
Good. All right. Amira, let's continue. Let's start a few more questions, maybe 3, 4. That will be enough. After that, if you have time, you will start a new chapter. Okay, our second chapter will be about indices, surds, and the standard form of a number. All right. So, question 10. Actually, I selected a few questions. The rest you'll practice yourself. These are all, I think, even numbered questions. I don't think I'm going to solve all of them, and I'm hoping that we can solve them. If you don't understand or if you think it is difficult, we may discuss them together here. All right, next question, Amira. Now, again, it's about quadratic equation. A wire of length 200 centimeters is cut into 2 parts. Okay, and each part is bent to form a square. If the area of the larger square is 9 times that of the smaller square, find the perimeter of the larger square. Okay, that's the question. Maybe we should just, it may not be clear for us, then we have to reread it a bit slower, and after that we try to understand and use a variable. And since we are talking about something, right, that is related to geometry, the first step we have to draw. Okay, since we are talking about a wire of length 200 centimeters, so we have a kind of wire here. It doesn't have to be straight, so the length is 200 centimeters. Okay, and is cut into 2 parts. All right, from here I am cutting this. Okay, that is the first part, and this is the second part. Maybe this part is, one part is longer, the second part. Okay, so the whole length of the wire is 200 centimeters. Okay, and each part is bent to form a square. All right, taking this piece, right, we form a square. This is our square. And taking this piece and also bending and forming, since it is shorter, it will be a bit smaller square. If the area of the largest square, so let's say this area is something, this area is something, 9 times that of the smaller square, find the perimeter of the larger square. So we need to find the perimeter of this larger square. Okay, that's the question. So now we have to change this or convert this into mathematical problem. Okay. That means that using some variables and for operation, that is plus, minus, division, what is it, multiplication, we need to form, change this into mathematical problem. Now, my first question for you, Amira, here a wire of length 200 centimeters is cut into 2 parts. Okay, so let's say this part is X. Then what is the length of the second part?
200 take away X.
Very good. All right. In the second part, it says that if the area of the larger square is 9 times that of the smaller square. So we don't know the area of the smaller square, right? Let's say it is capital A. Then what must be the area of this bigger square?
9A.
9A. Good. So now the length of this wire is X centimeters. And this is a square, that means all sides are equal. Okay. Now what is the length of one side of this square in terms of X?
X divided by 4.
That's correct. And how about this one? All sides are equal, right? What is one side of the square?
200 take away X divided by 4.
Very good. So now we know how to write this area. Now we're going to write our equation here. What is the area of the square? It is 9a equals, how do you find the area of the square? One side squared, right? One side is x over 4, that is squared. Okay, and how about for this square, the small one, it is a, that's equal to 200 minus x over 4 squared. So these a's are the same, right? So here it says that find the perimeter of the largest square. What is the perimeter of the largest square? X over 4, x over 4, x over 4, x over 4. That's equal to x. So this perimeter is equal to x. We are looking for the value of this x. So now we got the equation. Next, what is next? How can we solve this equation? Substitute this thing for a, right? Because here we have capital A. So we have 9 times a equals this, 200 minus x over 4 squared equals, on the right hand side, x over 4 squared. Okay. What is next, Amira?
We need to work out what x is.
Good. We can work out, but how? Do you think that I need to expand this and take to the left hand side for the equation?
Yeah.
Okay, that's one method, but I think I'm going to use different method here. If I bring this 9 inside the parentheses, what we have here? Here we have 3 over 4 times 200 minus x, right? Here we have something squared equals, on the right hand side, we have x over 4 squared. I think this way is much better. Right? I can take this out. 3 squared is 9 here. So from here, what we have here? Did you understand this step?
Yeah.
Good. Now, what we have here? We have something like this. Here we have something like maybe x squared is equal to, let's say, y squared. I mean, if x squared equals y squared, what is x?
X is equal to y.
Plus minus y. Right?
Okay.
Because if it is positive y squared equals y squared, negative y squared, again, it's equal to y squared. So instead of solving quadratic equation, I can just solve these two equations. Number one is this 3 over 4, 200 minus x equals, on the right hand side, here we have x over 4, or 3 over 4, 200 minus x equals minus x over 4. It's just a linear equation, right? So if you solve this, what we have here, this 4, they cancel each other. If you remove the brackets here, we have 600 minus 3x. On the right hand side, we have x, right? Take to the right hand side, 4x divided by 4. So x is equal to 150. That is a solution. Much easier than solving quadratic equation. How about here? This 4 cancel each other. Here we have 600 minus 3x equals minus x, right? Take to this side. It is minus x plus 3x. That is 2x. Then x is equal to 2x, 300, right? Okay. We have two possible answers. So which one should we pick here as an answer? Both, or only one, or the second one?
We need to pick only one.
So which one is the answer?
X, the first one.
The first one.
Yeah.
How about the second one? Why it's not the answer? It cannot be the answer.
Because it's bigger than 200.
It is bigger than 200, right? Because if you divide 200, I mean, a piece of wire which is 200 into 2 pieces, each piece must be less than 200. So that's rejected. So x is the perimeter of this, right? So the perimeter of the bigger square is actually is p, 150 centimeters. Very good. Amira, maybe this is the last question. Okay, that much is enough. We have a lot of problems, but maybe you will do them first. You try, and if you cannot solve, or if you think it is, I mean, a bit confusing, or you cannot solve that question, then let's solve those questions together. Okay, next Thursday or Friday. Okay, and I'm going to stop solving this kind of questions. I mean, related to quadratic equations. That much is enough. So that is the last question. A group of students is on a sightseeing tour. Okay, a group of students. How many students? We don't know. Immediately that comes to our mind. The total fare is $120. And this is to be shared equally among the students. All right, so how many students we have here? We don't know. Let's say it is N. And the total fare is 120, and this is to be shared equally among the students. So if they share this cost equally, so each student pays how much then? In the first case, so each student pays how much? The total is $120, and altogether N students are coming, right? So each student should pay how much?
120 divided by N.
120 divided by N. Very good. That is what it means, right? The whole sentence means this. If two more students join the tour, that means that now if we have not N plus 2 students, then each will pay $2 less. All right. Second case is 2 more students coming, then 120, the total cost does not change. Now we have 2 more students, right? This is each student pays. But now, since now we have more students, each student pay less. By how much? $2, right? In the second case, each student is going to pay this much for the tour. The question is, find the original number of students in the group. If 2 more students join the tour, right? So, is that correct?
What is correct?
I think I should write 2 less. I just keep this here. So if 2 more students come here, actually they need to pay. So now we're students 2 plus N plus 10, right? Okay. All right. So in the first case, that is each student should pay, that is X sub $1, and here X2 sub $2, right? So here the students are paying less. So the difference should be equal to 2, is it? Because that each student, we are expecting that every student should pay this much. Now, if we have 2 more students, each student should pay this much. So it says that if 2 more students join the tour, each will pay $2 less. So that is 120 over N minus and 120 over N plus 2. That is equal to 2, right?
Yeah.
Okay. Then here 120 is a common factor. The rest is easy. Here we have the common denominator will be N times N plus 2. So here we have N plus 2 minus N over N squared plus 2N. That is equal to 2. So these two things cancel each other. On the right-hand side, we have 2, right? What we have here, N squared plus 2N, that's equal to 120. Or N squared plus 2N minus 120, that's equal to 0. That is 12 times negative 10, 12 plus negative 10. So N plus 12 and N minus 10 is equal to 0. N equals negative 12 or N equals 10. And since N represents the number of students here, this answer is rejects. So answer is 10. What is the question? Find the original number of students in the group. So the original number of students in the group is 10. I mean, is that much enough for quadratic equations? So now we are hoping that actually you have, I think, enough knowledge and You're a good student. If you practice a few more questions, you can solve any kind of quadratic equation and also word problems. And hopefully, now we will get back to quadratic functions a bit later. Okay, what we have to learn about quadratic equation. Now we have to consider this as a function. Okay, as a function means here so far what we actually know is if you're given any quadratic expression, that is ax squared plus bx plus c, you studied how to factorize this or how to deal with this kind of expressions. If you're given 2, we can know how to add it, how to subtract, blah, blah, blah. And number 2 is, in this chapter, we learn how to solve quadratic equation. Ax squared plus bx plus c is equal to 0. All are real numbers and a is not equal to 0. That much is done, okay? And what we have learned here is we learn how to solve quadratic equations analytically. That means algebraically, right? Using the formula. So later we are going to learn how to solve this equation. We just consider this as quadratic function, ax squared plus bx plus c. And also we will actually get back to this quadratic equation and solve this graphically. Okay, sometimes there may be a question. We know that the graph of quadratic function is parabola. Either it looks upward or downward. So we need to find it as x-intercepts. These are the solutions of this function. That is what we have learned here by using that formula. Okay, and also we will study when it looks upward, when it looks downward. All right, what is it is here minimum point? If it looks downward, for example, if it looks downward, for example, we need to find this maximum value. If it looks upward, for example, we need to find this minimum value. Where does it cross the x-axis? Where does it cross the y-axis? We call them y-intercept, x-intercept, blah, blah, blah. Okay, the things, we'll get back to this a bit later. Okay, but for now, that much is enough. So you know how to solve quadratic equation by using the formula, and also you can solve equations that leads to quadratic equations and also problems involving quadratic equations. Okay, you actually try to solve problems in this chapter and submit to me as many as you can by maybe Friday, whenever you are done. So I'm closing these slides. Okay. This chapter 2, I will send you the worksheets soon. Okay. All right. Amira, this chapter 2, is about indices, surds, and standard form. Okay. I just split this into 2. The first part, we are going to talk about indices and standard form. These indices, we are just going to have a look at very fundamental concepts, okay? And what do we mean by indices? How do we deal with indices or expressions that involve exponents? How do we add? How do we subtract? And we'll talk about its properties. And after that, we'll talk about the standard form of a number, okay? So in part B of this chapter, we'll talk about more indices and surds, okay? And that's all about this chapter. And also we'll go very fast. I think it's not going to take a long time. Maybe 2 or 3 sessions, we will cover the whole chapter. Okay. Now, all right, you will read these things later. Now I'm going to start with some properties of indices, okay? That is index, or we just call this exponent or exponential expression. All right, depending on the books, they use some different terminologies. All right, so now let's start with the idea of index. We know that in math, if you just add a number to itself a few times, for example, For example, here we have a plus a plus a, right? And actually, before mathematicians introduced multiplication, they used to write numbers like this. And after that, every time writing this in a long way, it's not so practical. Then they had a kind of feeling that they have to introduce new notation, right? That is multiplication. Okay, if a number is added by itself n times, simply in a more compact form, we can just write it as 3 times a. That means that this a is added to itself 3 times. That is how it started, okay? And similar to this, and also actually years past maybe, and also mathematicians, when they are actually doing their work, they actually encounter this kind of situation now. How about a number is multiplied by itself many times? Maybe here a number is multiplied by itself 3 times or 4 times or 10 times, sometimes a lot, maybe 50 times. How do we write this in compact form? Every time writing in this way, it is not practical, like 2 times 2 times 2 or 3 times 3 times 3, right? So they introduce a new notation, that is index or superscript notation. Here we have a, we just write a, and just small number here. How many times is it multiplied to itself? Now here we have just write 3, right? And how do you read this? It is a to the power of 3, or third power of a. So here we call this base, right? And we call this exponent or index, or we just superscript notation to the right. And how I'm going to read this? Just a to the power 3. Anyway, so now this is how we define these exponential expressions, okay? This exponent here we have, if you're given any number, a real number, okay, any integer, let's say here positive integer. Positive integer means that 1, 2, 3, 4. So what we mean by this notation, a to the power of n, okay? So we are defining this as this number is multiplied by itself n times. So that means that here we have a times dot dot dot. Here we have a. So this a is multiplied by itself n times. That is a keyword. I mean, that is the most important concept in this chapter. Now, what we are going to learn here is everything is based on this idea. Okay, using this idea, we can have some properties of these indices. Okay, so now we have this definition. So the first property says that, okay, if it is so, now if you multiply a to the power n by a to the power n, to simplify this, just write one base and add their exponents. So here we have n plus n, right? And why is it so? Again, we are just using this idea. According to this definition, what does this a to the power n mean? It means a times dot dot dot. Here we have a. How many a's we have? N times. Now the second term here. Here we have a times dot dot a. So here we have m a's, right? Now again, using this definition. All right, here how many a's are multiplied by each other? Here we have n, here we have m. By counting principle, altogether here we have m plus n a's. Then in a compact form, using this definition, I can write it as a to the power m plus n, or n plus m, doesn't matter. That is the first important property of indices. And the second property is, that is division law. It says that if you have here a to the power m over a to the power n, here I am assuming that a is not equal to 0, because we know that in real number system, we do not have 0 division. We cannot divide any number by 0. That's why here we have exception. Again, using the definition, what does it mean? It means that here a is multiplied by itself. How many times? M times. Here we have m. And here we have a times, here we have a, and multiplied by itself n times. Now, actually, these are all things are equal, right? Common factors. So we can cancel out as many as we have in the denominator, right? So if we just cancel out here, for example, if we have 8 here, if we have 3 here, 3 is gone. How many left here? 5. The difference of m and n. So here we can write it than a to the power m minus m. Okay. So here we are assuming that m is greater than n. How about if n is greater than m? At the time, I can just write it as 1 over h to the power n minus m. That is the division law of indices. And how about the multiplication and division laws? And also we'll start this a bit later. Let's see a few examples related to these two things. For example, these are very easy. I know that for you, but we need to have a look, and after that we will deal with some a bit more challenging questions. Using that multiplication law, here we have a squared times a cubed. What is it? We should just write a, right? Bases are the same, and add their exponents. So 2 plus 3, that's equal to a to the power 5. And how about here? Bases a, adding their exponents, that's equal to 7. In this example, simplify each of the following. That is equal to, we can do this mentally, of course, Amira, but in the exam, you need to show your work, right? Because in GCS, they require that you need to show all your work, every step. That's why you need to write first here 4 to the power 5 plus 6. Then you should write the answer. But I'm hoping that you can do that. That's why I'm skipping this step. Okay. Here, how about here? Multiplied, bases are the same, so we should just add their exponent. So 7 plus 2, it is 7 plus 2, that's equal to a to the power 9. And how about here? Here we have something, one algebraic term, another algebraic term, and we know that to multiply one algebraic term by another algebraic term, first we need to multiply coefficients by the coefficients and variables by variables. So here we have 5 times 6, that is 30 times, and bases are equal, the same, x multiply, so we should add their exponents, 2 plus 4, that's equal to 6. Equals, how about here? We have one algebraic term here, multiplied by another algebraic term. So all are multiplied. Here we have x to the power 3 plus x to the power 6. So 3 plus 6, that's equal to 9. Now here we have y squared, y to the power 5, 2 plus 5, that's equal to 7. Simplifying the given, what is it, indices or algebraic expressions involving indices. Again, here we have two algebraic terms, multiply the coefficients, 4 times 3, that is 12. And like terms, I mean the variables here, h to the power 6, h squared multiplied, so we should add their exponents, 6 plus 2, that is 8. And here we have k to the power 5 times k to the power 4, that's equal to 9. Okay, using multiplication laws. How about division? Just division here, a, so a to the power 5 is divided by a squared. So we should just write first in fraction form. You can do it, of course, mentally. Then here we have a to the power 5 minus 2. That's equal to a cubed. I mean, showing your steps. In the exam, this is what you have to do. But now we can just do this mentally. Okay, bases are equal. So 5 minus 2, the answer is a cubed. B, again, here we can write the first in fraction form, a to the power 7, a to the power 3, and here we have a to the power 3 minus 7 minus 3, that's equal to a to the power 4. All right, in a similar way, here we have divisions, a to the power 9 divided by a squared. So that is 8 to the power 9 minus 2, that is a to the power 7. How about this thing? It is divided, x to the power 8, so it is minus 4, that is x to the power 4. And how about here? Sometimes students may get confused because here we have one term divided by another term. That means that if you get confused, write it in fraction form. That means 12 times h to the power 6 over 4h squared. 12 over 4, that's equal to 3. H to the power 6 divided by h squared, so bases are the same. We need to subtract their exponents, 6 minus 2, that's equal to 4. So the answer is 3 times h to the power 4. How about here? X cubed times y to the power 7 over x times y cubed. So here we have all are multiplied, so we can just cancel out the common factors. X cubed is divided by X, that is X squared times Y, 7 minus 3, that's equal to 4. Okay? Amira, when did you learn this indices? Last year or this year?
I learned this like 2 years ago.
In grade 8 or 9?
I learned this in grade 8 at the beginning.
Okay, good. Power law of indices. What we have here we are going to apply this law here. A to the power m to the power n. Sometimes students get confused with this. They just write this a to the power m to the power n. It's not like this, right? That's equal to just a to the power m times n. It means this. Why is it so? Because by definition, a to the power m to the power n means here we have a to the power m times a to the power m times dot dot a to the power m, right? Something to the power n. So how many a to the power n's we have here? N, right? So by definition, again, here we just write here the expression, and here we have n, right? Because here we have m plus m plus m, right? We're just adding using the definition. Actually, here we have something like this: a to the power m plus m plus m dot 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 plus m. And how many m's we have here? Since we have n terms here, we need to have here n m's. Again, by the definition addition, here we have m times n. So that's equal to n times m. Okay, using this, the first one is a cubed squared, that's equal to a to the power 3 times 2 equals a to the power 6. That is how you have to do this. In real life, of course, we can do this mentally once again, but in the exam, you need to show your steps like this. How about here, a squared to the power 6. That's equal to a to the power 2 times 6, a to the power 12. Some more examples. Let's do this quickly. Here we have 3 to the power 4 times 4, that is 16. X to the power 3 times 5, that's equal to 15. First, we have to simplify this. Remove the brackets. X to the power 6 times 5, 30 times 3, x to the power 7. So here we have 1 times 3, that's equal to 3. X to the power 30 times x to the power 7. So we need to add their exponents. That's equal to 37. And division, again, you can just write in fraction or subtract this. 7 times 4, 28 over x to the power 6. That is x to the power 28 minus 6, x to the power 22. More laws of indices. Here we are going to use another one. If you notice here, bases are different. Here we have the bases 2, bases 3, but the exponents are the same. At the time, here we have something like this: a to the power n times b to the power n, right? Now that's equal to, I can just write it as, since here we have y actually is equal to a times b to the power n. Why? The reason is, again, by using the definition for every property. To prove the property means small theorem. We have to use the definition. So by definition, what is this? It means it is a times a times a dot 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 a. How many a's? Here we have n a's. Times, now here we have b to the power n. b times dot 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 b. So here, how many b's we have? N. Now I'm going to use this property of algebra. We know that a times b equals b times a. We call this commutative property, right? 3 times 2 equals 2 times 3. In general, a times b equals b times a. So I can just interchange this and write it as a times b with these two. The first one times, second one is the second one, AB times AB dot dot. Here we have AB. Because here we have equal number of A's and B's, right? So we can just pair them. Now, how many AB's we have? N, right? So again, by definition, then I can write it as A times B to the power N. And that's why A to the power N times B to the power N, that's equal to A times B to the power N. So using this property, we can just solve this or simplify this. 2 to the power 3 times 3 to the power 3. That's equal to 2 times 3 to the power 3, which is equal to 6 cubed. And B, 9 squared times 8 squared. Again, powers are the same, bases are different. I can write it as 9 times A to the power 2, which is equal to 72 squared. All right. Amira, are you there?
Yeah, I'm right here. I'm listening.
Amira, why don't you try using the surface? Because some questions may be easy. You just do this and I will watch you, or you don't want to write anything on the screen.
Well, I want to write, but I don't know how. It doesn't let me.
Now, do you have a pencil?
Yeah, I do.
Okay, let me just try one thing. Is it because I do not allow you to share our screen? Let me just click this. Participants, new share, pause, animate, security. Okay. Disable possibility. High video share, computer sound. Interesting. Why you cannot write? There must be invites. Chat. Ask. Okay. Make host. No. Okay. I mean, I will have a look. Also, if you have time, can you just also search on the internet? How can I write on the share screen in Zoom?
Okay.
If you are not a host, okay? You try this maybe next time. What do we have here? I mean, let's solve 0, negative, more laws. Okay. 2 examples, and I'll finish the class. Okay. All right. Express each of the following as a power of a single number. Okay, and also there are a lot of questions in GCSE and A level. So they just ask you to measure your knowledge. Do you know this property or not? So here we have using that property again, if we have A to the power N is divided by B to the power N, using the same thing, bases are different, but exponents are the same. So we can write it as A over B to the power N. So for A, 3 squared is divided by 5 squared. Exponents are the same. We can write it as x 3 over 5 to the power 2. So we just write it as a power of a single number. The single number is 3 over 5, one fraction, or 0.6. And B, how about here? That is equal to, exponents are the same. We can write it as 4 over 7 to the power 3. It's a single number. The last example for today, simplify each of the following. A, simplify means we need to clear the brackets or parentheses. So here we have 4 cubed. A, 3 times 3, it is 9. B cubed. Or 64 times 8 to the power 9. B cubed. If it is a small number, we can just raise to this power. Otherwise, we can leave it as an exponential expression. How about B? Here we have square. So -2 squared, that is 4. X squared, that is x squared. Y squared squared, that is 2 times 2, y to the power 4. And how about C? Here we have first simplify clear this parenthesis, and after that this, then we can multiply them together. So the first one is 2 to the power 4, that is 16, and a squared to the power 4, that is a to the power 8. Sometimes students added 6, actually we should multiply them. B to the power 3 times 4, that is 12, times, second one is a cubed to the power 3, that is a to the power 9. And this one is b cubed, which is equal to, now let's simplify this. Here we have a to the power 8 is multiplied by a to the power 9. So we should add their exponents. 8 plus 9 is 17. And now here we have b to the power 12, and b cubed. Multiply 12 plus 3, that is 15. Okay. Amira, that much is enough for today. Now I will send you this paper, okay? And as I told you, maybe you studied this before. We are doing some kind of revision, all right? So have a look and try to solve these questions. You don't have to solve all the questions. If they are too easy, you can just tick and skip these questions. Maybe out of 10 questions, if you do 4 and 5, it would be great, okay? Hopefully on Monday we will do some more on indices, surds, and standard form, and I'll try to finish this chapter, and in this way we'll continue. Now I will send you this PDF, this worksheet for chapter 2. After you finish chapter 1, also you should start this, okay?
Okay.
If you have any questions anytime, you are welcome. All right, thank you very much. See you on Monday. Not Monday,
Yeah.
Friday.
Friday, yeah.
Friday, yeah. Okay, Amira, bye-bye.
Okay, goodbye.
Bye-bye.